Mean, median, mode, we've heard of those before. Bimodal just means we can have more than one mode. And then we did this example in the video. If you haven't watched it, go back and watch it. Okay, so although the mean, median, and mode, which describe a typical entry of a data set, there are advantages and disadvantages of using each. I'll come find you at lunch. It's okay. Okay, so the mean is a reliable measure because it takes into account every entry of a data set. However, the mean can be greatly affected when the data set contains an outlier. Okay, and we kind of talked about outlier already, but again, it is a data entry. That is far removed from the other entries of a data set. Okay. And the key thing here is that it greatly affects the mean. Okay, so we're going to look at a sample of students in the class, or ages of them. We're going to find the mean, the median, and the mode. And then we're going to talk about which measure of central tendency describes a typical entry. Okay. So how do we find the mean? Let's review. How do we find the mean? Don't make it hard. How do you find mean or average? Add them all together, okay? And since this is a sample, we're gonna be finding X bar, okay? So add up all of those ages, and what do you get? You add them before dividing. You add them all up, what do you get? $475. And then what are we going to divide by? How many numbers are there? 20. Okay, so if we divide that, what do you get? What'd you get? That one's better. So 23.75. If anybody remember that watched the video, what's the round off rule for mean? Correct. So we started with whole numbers. So our round off rule says we're going to have one more decimal than what we started with. So I'm going to use RR to round off rule. So this would be 23 point what? 8. There's your mean. Okay, how do we find median? We're finding the what? The middle. So go through and cross them off. I just lost where it was. So we have two numbers in the middle. Okay, 21 and 22. So how do we find the median of those?
Add them together, divide by 2.
Add them together and divide by 2. So 21 plus 22 divided by 2, what's our median?
21.5.
21.5. And then what's the mode? 20. All right. So which measure of central tendency best describes a typical data entry? So all those ages are approximately what? Are they all around 23.8? Are they all around 21.5? Or are they all around 20? What best represents the center?
21.5.
21.5, okay. So our median best describes the center because it's not affected by the outlier. What is the outlier?
65.
65. Okay. And one thing to remember, like when you're looking at this, why would there be a high school student that's 65 or 24? This is a college textbook, so that's why. So like if you're looking at your college class, that's probably a good representation of the ages of your students, okay? Or your peers. Okay, so now what if we remove the data entry of 65 and then rework it? Okay, so for our mean, don't do a bunch of work. Okay, we found the sum to be 475, right? And we're gonna remove what? 65. And then we had 20 numbers and we removed 1. Okay, so now we have 410 divided by 19. If we divide that and use our round off rule, what do we get? 21.6. Okay. If we take off this 65, that's no longer there. Okay. Our median is going to shift to the left. So instead of being in between, our median would be 21. Bless you. And then what is the mode? 20. So now which one represents the center the best? And it's going to be the mean. It shows more of the center. Because it includes all the data entries. The median really only includes one data value versus the mean takes in all of them into effect. Okay. Questions on that? Okay. Looking at, then we talked about weighted mean. Okay, we talked about how weighted mean is how we find like GPA, how we find like our grade in a math class or any of your classes. Okay. And we can use that process again when we find the mean of a frequency distribution. It's very similar, okay? So we're gonna do this example together. So use the frequency distribution below, approximate the mean number of minutes that sample of internet subscribers spent online during their most recent session, okay? Our first step was to find the midpoints. And this is bottom of page 14. Okay, so first thing we wanna do is find the midpoints. Do we need to find them or are they given to us?
Given.
They're given, okay? Class midpoint, we're good. Step 1, done. Step 2, find the sum of the products. So we need to find the products first. So we're gonna take X times F. So multiply your 2 columns together. So what's 12.5 times 6? 75. 24.5 times 10? 245. 36.5 times 13? 474.5. 48.5 times 8. 388. 60.5 times 5. 302.5. 72.5 times 6. 435. And 84.5 times 2. 169. And now we're going to add those all up. So summation of x times f. Add those all up, and what do you get?
2,089.
2,089. Okay. And then we want to find the sum of the frequencies. So how many total numbers are there? What is the sum of the frequencies? It's given to you. 50. Okay, and this is the sum of the frequencies. Remember, n will always represent your sample size. How many data entries are there? 50. So now we can find our mean. So x bar equals the summation of x times f divided by n. We have 2,089 divided by 50. And what do you get?
41.8.
41.8. Why is it 0.8 and not 2 decimal places?
Rounding rule.
The rounding rule. Okay, so if you divide 2,089 by 50, you get 41.78. Okay. But our midpoints are something we had to calculate. Okay. Your original data is whole numbers. Okay. So that's why we round to 1 decimal place. Does that make sense? Okay. All right, then the last thing we're going to talk about is our different shapes of data. Okay, so we have 4 main ones. So graphs reveal several characteristics of a frequency distribution. One such characteristic is the shape of it. Okay, so our first one is symmetric. And this is when the mean, the median, and the mode are all the same. Okay, so we can say when a vertical line can be drawn through the middle of a graph, resulting in mirror images. Resulting in mirror images. So you talked about symmetry and geometry. It's the same idea. Okay. This shape in particular is going to be one we talk about a lot second semester. This is called a bell-shaped graph. We're going to look at that when we look at normal distribution. Okay, uniform. And this is when all entries in the distribution have equal or approximately equal frequencies. Okay, so usually it looks like a box. Okay, it can be like one bar could be a little bit higher every once in a while. Okay, that's still considered uniform. Okay. Uniform is also what? Can we draw a vertical line and cut that in half? Yeah. So this is also symmetric. But when we're describing shape, we always want to be as precise as possible, okay? Or as specific as possible. Okay, last two, skewed left and skewed right. You can also say negatively skewed, positively skewed. This is all about where's the tail. Easiest way to remember, okay? On this first one, it's skewed left because the tail is on the left. Okay. And that's literally the definition. Is when the tail of the graph extends to the left. Okay. The key thing with this is that our mean is less than our median. Okay. The easiest way to remember that, mean alphabetically comes before median, so always write in that order, and then do your inequality pointing to the direction of the tail. Okay. So for skewed right is when the tail of the graph extends to the right. Which means the mean is greater than the median. Okay. So the way your book describes that is that the mean will always fall in the direction in which the distribution is skewed. Okay. Those are your different shapes of your graph. Okay.